we're still in section 3.1. But we're going to be talking about a different skill today. Rather than going from the equation of a sinusoid to its graph, we're going to go from the graph to the equation. Okay with that plan? So, first things first, to do this, I could have many possible answers depending on whether I choose to use a sine function or a cosine function, and depending on which points I'm going to be looking at to kind of determine my values for, specifically the value for h. Can kind of really have a big impact on what my equation looks like. So I'm going to write two sets of answers. I'm going to write the answer once as a sine function and once as a cosine function, just so to give you guys an idea of kind of what I'm looking for. Okay? So the first thing I'm going to do, regardless of the type of function that I'm going to be looking at, is determine the value for k. Remember, k is the midline, so I should have an equal amount of the graph above and below the midline. So if I look at this first graph, it appears that the midline is right here. Do you guys agree with that? That's the line y equals 1. That tells me that k is 1. Everybody okay with that? That's pretty easy. I can get that just by looking at the graph. I didn't have to do any calculation. Next thing I'm going to do is determine the value of c. I know that the period is equal to 2 pi times the absolute value of c. So what I'm going to do is determine the length of one period. So if I count from like maximum to maximum or minimum to minimum, I can determine the period. So let's say I want to go from this maximum to this maximum. So that's going from 0 to pi. So my period is just pi. Because that's the distance along the x coordinate. Okay with that? So if I then plug that in for my value for p, and divide both sides by 2 pi, I get that the absolute value of c is a half. Now, for all of these problems, I'm always going to have a little bit of freedom about choosing whether negatives or positives. But for c, I'm never going to choose a negative value. I'm always just going to choose c to be positive. It makes life much easier to think about it that way. So if we need to make a reflection, we're always going to use that reflection as a, or do a translation left or right instead of dealing with a reflecting of c. So I'm always going to pick c to be a positive. Okay? The next thing that I want to determine is my value for a. Remember, a is the amplitude. Or is related to the amplitude. The definition for the amplitude is it's the distance from an extrema to the midline. So for example, this length is an example. So that's 1 unit. Kendall? Divided both sides by 2 pi. So pi divided by 2 pi, the pi's cancel, and you're just left with 1 over 2. Is that okay? Okay. I said it out loud, but yep. That's okay. Now I'm going to stop before I find the h, because depending on whether we're talking about writing a sine or a cosine function, the h is going to be different. These other three, the absolute value of a, my value for c, and my value for k, will be the same regardless of whether I'm writing a sine function or a cosine function. But the sign on A and the value for H will likely be different, or could possibly be different. So I need to make sure that I've designated which situation I'm talking about before I go about finding those things. Okay with that plan? So let's start with cosine here. So if I want to write this as y equals cosine, what I need to do is find a point on cosine that I can relate back to one of the points on the parent function. So I'm going to look for a point on my graph that I'm going to relate back to the point 0, 1 from my parent function. I observe that the point 0, 1 on my parent function for cosine is a maximum. So in my transformed function, I want to pick another extreme point, either a maximum or a minimum. Now if I pick a maximum, that's going to tell me that my A needs to be positive. If I picked a minimum, that A would have to be negative. That's what TF stands for. It doesn't matter. You just need to pick a value. So I'm going to pick a maximum. The maximum that I can pick, I have some choices. Any of those are maximum. So let's pick one of those points. I'm going to pick the obvious one, which is, yeah, this one right here. Okay, so you have some choice. You're just going to pick one of the extreme points. You could pick a minimum also. That would be fine. If you pick the minimum, your A value needs to be negative. But I decided to pick a maximum, so it didn't affect the A value. And now what I'm going to do is I'm going to remember that to go from a point on my parent function to a transformed point, I do the transformation Cx plus H, Ay plus K. So what that says is that if I take my x coordinate from my parent function and I plug it into that expression, I should get the x coordinate in my transformed function. So I have that C times 0 plus H should give me 0. Well, what's C times 0 equal? 0, right? What's 0 plus H equal? 0, or just H. So I'm left with just H equals 0. So now I have everything I need. So I can write y equals positive 1 times cosine of 1/2 x minus 0. Oops, not 1/2 though, because it's the reciprocal of c. That should be 2 plus 1. And if you want, you could clean up that stuff inside the parentheses and just write that as 2x. Certainly that's fine. X minus 0 is x, and 2 times x is 2x. How is that going to change if I had picked, say, a sine function? Well, on sine, I want to use a midline point. And the midline point that I'm going to use from sine is the point 0, 0. So in my transformed function, I want to choose another midline point. So if I look at the graph of the parent function for sine, so this is the graph of sine. I notice that there's a point on the midline, 0, 0. Similarly, if I looked at the graph of cosine, they're like the reference points that you use for graphing, so they're the same. There's a maximum is at 0, 1. Okay? And really when I'm doing this, I'm always using the midline point 0, 0 for sine, and I'm always using the maximum point, for every time I do this. So I need to choose a midline point on my graph. So any of these locations are a midline point. Any of those would be acceptable, but they're not all the same. So I need to be a little bit careful. When I go back and I look at the parent function for sine, I notice surrounding this midline point of 0, 0, this part of my graph prior to that point is below the midline, and the part of the graph immediately following that midline point is above the midline. So I'm going to note that here with a down arrow saying the graph is below the midline, and then an up arrow after saying then the graph is above the midline. So I can pick any of these midline points. If I picked, say, this value as my midline point, I notice that prior to that midline point, our graph is above the midline, and following that midline point, our graph is below. Because those are opposites, what that tells me is that my A should be negative. So in this case, A would be negative 1. Now, I could just have easily picked a different midline point. If I picked that one instead, then my A would be positive. So it varies a little bit, but it doesn't really matter which one you pick as long as you account for the reflection that could occur there. Is everybody okay with that idea? Okay. So if I look at the coordinate for this point is at pi over 4, comma 1. I just read that from the graph. And then I can do the same thing. I'm going to transform my parent function to this new point by using cx plus h, ay plus k. Really, since all I'm worried about is the h, I'm going to do c times 0 plus h. Has to give me pi over 4. C times 0 is 0. 0 plus h is h. So that gives me just that h is pi over 4. So now I have everything I need. To write my sine function. So the tricky part is this part at the end where I have to figure out both the sine of A and the value for H. That's the tricky part. But once you've done it a couple of times, they're really all the same. So I know it feels like a lot all at once. It's really the same process, and once you have a handle on it, it becomes not so bad. Let's do another example. So let's look at this graph here. Where's the midline at? Y equals 0. Does everybody agree with that? The x-axis is the midline? Now let's determine the period. So notice that I don't have two maximums here, right? So I can't just go max to max or min to min, because I can't see two maxima or two minima. But what I do see is that from here all the way to here is one period. Do you guys agree with that? Because I have an up and then a down. So if I look at that, that's going from negative 2 pi over here to positive 2 pi over there. So that total length should be, or must be then 4 pi. You agree with that? If I start at negative 2 and I end at positive 2, I went 4 units, right? If I start at negative 2 pi and I end at positive 2 pi, I must have gone 4 pi units. Same idea. And because I know that 1 period is equal to 2 pi times c, if I then divide both sides of this by 2 pi, I get that the absolute value of c is 2. And because, like we said before, we're always just going to choose to use c as a positive, I'm just going to write positive 2 as my value for c. Everybody okay there? Next, let's figure out our amplitude. So the amplitude is the distance from the midline to an extrema. So that's my amplitude. How far is that? 2 units. So now we've figured out everything that we can that's not specific to whether we're using a sine or cosine function. So let's write the two equations. We'll write one as a sine one and one as a cosine one. You don't have to do both unless you're asked to supply both, but if you're not given one or the other to use, you could use either one, but I like talking about how to do it both ways. So again, let's start with cosine. So for cosine, I know I have a maximum point at 0, 1. My transform function, I could use either the maximum point here or the minimum point here. It doesn't really matter. Just for the sake of doing something different, I'm going to pick to use the minimum since we used the maximum last time. If I read this graph, that minimum point occurs at pi, comma, negative 2. So, to transform 0, 1 to pi, negative 2, the x-coordinate I did c times 0 plus h, and that should give me pi. Now, since I went max to min here, I know that the a is negative, so RA is negative 2. And now I have everything that I need to write my cosine function. So I have negative 2 times cosine of 1/2 x minus pi plus 0. Is everybody okay there? So let's do the same thing now for sine. So I'm going to start with the midline point for sine, and I know that the midline point for sine goes below, midline, and then above. So I'm going to indicate that with those arrows. For the transform function, I'm going to pick one of the midline points. So it doesn't really matter which one I choose. You could choose any one. For the sake of argument, I'm going to choose this one. So that is the point pi over 2. I'm sorry, not pi over 2. That's 2 pi, 0. And if I look at this point, prior to that midline point, the graph is below the midline. And following that, the graph will be above the midline. That tells me that my A is positive because the midlines are doing the same thing. So I can say that A is just going to be 2 in that case. And then if I do the same thing, I can go xy transformed to cx plus h, ay plus k. So I can do c times 0 plus h has to give me 2 pi, or that h is just going to be 2 pi. And here we have everything we need. So I can do y equals 2 times sine of 2x minus 2 pi plus 0. Okay with that?
Wouldn't it be 2 times sine times 1?
Oh yes, it should be 1/2. Thank you. I don't know why I goofed that. Yeah. Thank you, Zach. Everybody feel okay on that? Now it's going to take a little bit of practice, and you're going to have an opportunity to do that in the homeworks. But there is another type of problem I also want to talk about. So these problems, I think, are a little bit more challenging because you're not given as much information. So here it asks you to construct a sinusoid with an amplitude of 4, a period of 3 pi, and it passes through the point 3, 1. So the amplitude of 4 tells me the absolute value of A is equal to 4. The period of 3 pi tells me that 3 pi is equal to 2 pi, absolute value of C. So when I divide both sides by 2 pi, I get that the absolute value of C is equal to 3 over 2. Now, here we're not told whether we want a sine or a cosine function, so I'm free to pick. In the situation where I'm told that this is just some point, we're not told that point is a maximum, we're not told it's a minimum, we're not told it's a midline point, we're not told anything about it, I'm going to use sine, and I'm going to assume that this is a midline point. And the midline point, the behavior I'm going to assume is that it's this kind of a midline point. Because I'm not told any information about it, I can put it anywhere I want on my graph. That's the place where I'm going to put it. Because if I do that, then the A is positive, the C is positive, the H is my X coordinate, and my K is the Y coordinate. And I'm done. Now, if you don't pick that point to be that kind of a point, or you don't want to use sine, this becomes a much more complicated problem, but it doesn't have to be. So let's try to do it the easiest way possible, right? Okay. 4 is a bit more challenging. Here we're told that we have a sinusoid that has a minimum value at 510, and the next maximum is at 1532. So I'm going to start by just kind of sketching a little bit of a picture. So here's my minimum, and here's my next maximum. So my midline should be halfway through the middle of that, right? So to do that, I'm just going to take y max plus y min and divide it by 2. So that's going to be 21. Okay with that? The amplitude is that distance. So if this is 21 and that's 32, how far is this distance here got to be? 11, right? Alternatively, you could also say that you could do y max minus y min divided by 2. If you don't like doing visual, if you'd rather just use a formula, that's okay too. You'll get 11 that way as well. So we figured out now that k is 21. We know that the absolute value of a is 11. We still need to figure out the sign on a, whether it should be positive or negative 11. We'll figure that out in a moment. What I want to do next is figure out the period. So if I go from here to here on my graph, how much of a period is that? Because that's not a full period, right? For this to be a full period, it would need to be to do that. You guys agree? So that to me looks like half of a period. Do you guys agree with that? Just visually that should look like half a period. So that is the distance from 5 to 15. So one period then has to be 20. And I know that has to be equal to 2 pi absolute value c. So when I divide both sides by 2 pi, I get that the absolute value c is 10 over pi. And remember that we said we're always going to just use positive values for c. Now, the last thing I need to do is figure out the sign on a and my value for h. Because I'm given maximums and minimums, the trig function I'm going to use is always going to be cosine. Because on the parent function of cosine, I know about a maximum. In my transform function, I know about a maximum or a minimum, so I have my freedom to pick whichever one. I'm going to choose to use the maximum, but you could just as easily use the minimum. Because I'm using the maximum, I know going max to max, the a needs to be positive. And that transformation is cx plus h, ay plus k, so that my h just is going to be 15. And now I have everything that I need. Oops, that's supposed to be 21. And I'm done. So for next time, I'd like you guys to work on (7 to 8), 13 to 14. Don't leave yet, guys, because I have something else for you. And I'm going to give you these two handouts. I'm going to be gone tomorrow. We have our department meetings that day. So tomorrow in class, you guys can take time to work on these handouts as well. So I'm just going to set them on the podium here, and you can grab them on your way out. Should take one of each.